Okay, so first off, thank you for inviting me to attend. And everything we do is not aerospace, so it's a nice juxtaposition to Nikki's presentation. And so this is a pretty broad topic, but I am going to focus fairly nearly on just a few things. Just to introduce you to NIC Global. We manufacture, we're vertically integrated on sheet metal, and then we do a lot of high-level assembly. We source, we have a sourcing team over in China and throughout Asia, and everything we make is custom and highly configurable. And so this is just a picture of part of our plant in Woodinville, Washington. We really practice lean manufacturing in order to be globally competitive and try to present a total cost solution to our customers. These are our biggest customers. Schweitzer Engineering Laboratories over in Pullman, Phillips Medical. We supply to them in multiple cities. PACCAR, both Kenworth and Peterbilt heavy duty trucks. Simpson Strong Tie, Stryker, who bought Physio Control locally, and others. So this is our locations in the U.S. Plus we have an engineering office in China. So we have facilities throughout the U.S. manufacturing, and the equipment and operations. We have lots and lots of soft tooling, which we'll talk a little bit more about later. But lasers, turret presses, brake presses, stamping, both stage and progressive. A lot of robotics, and we're going to talk more about that. And then 3D scanning, pick-to-light systems, and our ERP system is totally integrated. We have everything in there from maintenance to our inventories and purchasing and financials, and just we fully use the ERP system. And then we also do in-house powder coat, wet paint, and chem treat. So when I think about manufacturing in the U.S., I joined NIC in 2000, and shortly, a couple of years later, most of the big customers we had came to us and said, hey, we're going to move these basically all of our highest volume parts offshore. And it was, within 6 months, we'd lost 2 of our biggest customers, and it was a big gut punch. And really what was left was the lower volume, higher complexity products. And we had to take a step back and say, how can we be competitive and really be able to be profitable on that type of product? And just, example of product these are coin counting machines for Coinstar that we did. And they were about 1,500 units a year, and 650 different lower level components would go into to make these units total turnkey product. And it was very hard because they're big and complex and low volume for them to move those offshore. So this is just representative of the type of work that is more commonly left in the US. So most of our work is what's called soft tooled, and I'm sure most of you know about this being in the manufacturing engineering, but everything, for example, on the sheet metal, this just shows a turret press and all of the tools that are put in there to form different features, a hex shape, a cutting tool, and they're highly configurable so that you can run a couple hundred pieces relatively efficiently before you have to change out tools. And we do a lot of work around commonizing the setup as much as we can and running like parts across it in order to reduce or eliminate setup. And the other parts that were left in the US were really the large and custom part assemblies. It's pretty expensive to ship. You can see that part there that this gentleman's assembling in our Ohio plant. You don't want to ship this from Vietnam. And so the bigger parts tended to be left here in the US as well. So as we continue on in manufacturing, the quality expectations continue to increase on us. It's not uncommon for our customers to want 10 ppm to 500 ppm. And that, as you guys know, is very difficult, particularly in lower volume, higher complexity, very human dependent labor product. And there's no way you're going to get there through inspection or, training the operator or anything like that. That just isn't going to do it. And so you really need to come up with technical solutions to solve quality issues. And we're going to talk about that. So the way I see the market dynamics right now, as I just said, the increasing quality expectations in our workforce, they're just it's really, really tough in the labor market right now. People are not going into the vocational skills training. It's very unusual for us to have someone walk in the door that knows how to operate a press brake or a turret press or something like that. And it's just very tough to bring in skilled workers. And then our customers are really, having gone through the pandemic and the logistics challenges, as Nikki was saying, with the empty shelves, they are looking for, it's an opportunity for us, and I'll talk about that too, to serve them domestically instead of bringing in a product. And so when I think about the US manufacturers, it's a balancing act between the labor force, quality requirements, logistics, and then you have these low cost centers down below that are always threatening to be there in the event that this falls over. And it's really, manufacturing engineering that's going to keep us balanced and lift us up and make us successful as a company in an industry in the US. So how do we adapt for higher quality performance and lower cost production? To me, we have to be clever and really utilize engineering to solve these problems. And I'm going to touch on these 4 areas of what we've implemented or in the process of implementing to improve our quality, improve our efficiency, and be able to manage those higher complexity challenges. So pick-to-light, camera inspection and 3D scanning, 3D printing, and cobots. So throughout our plants, we have what's called pick-to-light, and you guys probably are familiar with this, but particularly when it's a variable product, there's multiple versions of the same basic assembly. This, there's a visual work instruction, and in each step, the part that the operator is supposed to pick, this flashes, and it tells them how many they need. It might say 3 or something like that. They hit the button, they pick the 3, it shows them where to put it, they install it, and then the next button starts to flash and they grab that one. And this is a very complex assembly that this line does, and there's 5 stations along here with probably 50 parts at each station. And this has been very successful in terms of quality improvements and doing the right versions each time. The inspection technologies, there's the traditional stuff. We do, of course, a lot of sheet metal. And this is just a laser inspection system that every single time we set up a turret, you throw the part on there and it scans it and overlays it with the CAD data and says, yep, you've got all the right tools in the right place. We've also, over the last couple of years, brought in 3D laser scanners. You can see he's scanning just this little casting showing up over here. These are great for quick checks, particularly with more complex 3-dimensional curves and things of that nature that if you're going to do it in the traditional CMM way would take a lot more time. But we do have CMMs, which has kind of become a dated equipment, but we have those at all of our plants, and it's needed for first articles, PPAPs, things like that. So over the last couple of years, we've really embraced camera inspections, and my preference is to have quality built into the process, but we do so much variation. Like this particular part you see there is the firewall for a Peterbilt truck. And all of the many of the features in it are variable. And so we have to stamp, and this is a stamp part. So we stamp the versions. I think there's 20 versions of it. So we'll stamp them and we put them in with pick-to-light in sections. And so then the operator gets a list of parts that they need to build in sequence or pick in sequence. And the light shows up, we put it on, they carry it and they put it on this screen here. The camera takes an image of it and it compares it to the geometry for that particular part number and says, is it a match? If it's a match, it prints out the part label, the chassis VIN number that the actual truck it's going to end up on, the line sequence, the date, all that stuff. And then the part goes into a rack that then is presented to Peterbilt in the sequence that they need them. And so this validates we're doing the right one. It puts it in the right sequence, and the camera basically says, yep, and you know it's the right one because the label prints out. And every part has to have a label. If no label prints out, then the operator also knows, in addition to the image, that it's not the right one. It's pretty cool. This is a medical cart that we do, and it's assembled by humans because it's kind of lower volume and about 30 a day, and to really have robotic assembly on that would be quite expensive. And so we have been in the process of implementing a camera inspection system with a cobot. This is just a quick partial video. And this camera system's looking at 140 different items, like hardware, ITW brackets, things like that, other all the brackets and harnesses. And if it inspects something and it's not there, it stops right at that item so the operator knows, oh, this is where the missing item is. And then it also shows them which one's missing. So it's really a cool solution to, again, a manual process of putting the units together that it's hard to get to 10 ppm when you have people assembling them, even with the pick-to-light. I was just going to highlight here a couple of the lean. We really practice lean manufacturing, waste elimination. And this is a product for Schweitzer Engineering Laboratories. And there's, I think, about 10 different versions of this particular cabinet. And we have a cell set up where the operators insert the hardware and do all the bends in this little cell right here. And then it feeds into robotic weld, and then it comes off. And all of these little colored caps you see there are to mask the hardware. And they have a really special requirement where you can only have 1.5, they want to have 1.5 threads showing for the studs, for example. So we custom tooled up and color coded all of the masking units so that the operators knew they were putting the right ones on, and we would have the right amount of threads still showing. So that's just kind of a clever, simple way to solve that. This is just another example of, with the, because most of our volume ranges from 25 a year to 100,000 a year. And if we're doing something that's 100,000 a year, it's going to be hard stamped. But a lot of our work is in that 500 a month range. And so we have a huge quantity of different versions of parts. And so to try to eliminate setup, we've categorized them by bend style, gauge, things of that nature, so that we can put cells in with minimum or no setup between parts. And we can run a whole bunch of different parts, not even necessarily from the same customer, but has the same basic features or similarities. And that really helps drive out setup and make us more competitive. 3D printing, I think you guys are probably all familiar with this, but I think 100 years ago when I was in engineering, it was very expensive and slow to 3D print something. And now I cannot tell you how much we use the 3D printers. It's just everything from, you can see this is a press brake tool, check fixtures, prototypes. If they're small, you can scale them, and just it's something that, as for the students out there, really get to know your 3D printing and what you're capable of, what's capable of. And the last topic is the cobots. This to me is probably the biggest opportunity for really shaking up manufacturing domestically. And traditional robotic cells, this is in our Ohio plant, they're caged. You can't go in there. Here's the humans standing around the outside looking at it. And this is a a very complex and expensive cell, which is fine. But you also have to have the volume that makes it make sense from a financial perspective to invest in the capital and all that kind of stuff. And on when you're doing a high variation and lower volume, it makes that tough. So this cobot, humans can stand right next to it. It bumps into you, it stops. And many times they're doing fairly simple tasks, and the operator can actually train it. Say maybe they're switching jobs and they need to pick it up and set it on a pallet. They can just quickly train it, and it doesn't have to go back through engineering or anything like that. So we've you saw the inspection cobot that is doing the medical cart, but this is a cobot cell we put in our Nashville plant. And the reason we did this one is the part itself is quite heavy. This is the flat pattern, and an operator having to do these part engravings, spot welding the nuts on, and then bending it would make it a couple hours, and we'd have to be rotating them because of just the weight of the part. And we thought we can get a cobot to do this. And so it picks up the part. It actually has to put it into a jig it has to be, this is something we learned, it has to be exact. And then it sets it on a graver, engraves the needed information about the part mark and customer. Then it spot welds on several nuts. And then it comes over and it puts 2 bends in the part on the brake, and then this is it setting the part down on a conveyor, and it feeds it into the cage, and then it goes to powder coat after that. So here's a cell that you don't have to have a skilled operator to do all the heavy lifting on this. They show up every day. It's anyway, this is just a 10 from our perspective on being able to solve a manufacturing. The quality is going to be consistent. Everything is just really good. And so, just especially for the students, robotics and if you can get familiar with robotics, it's where we need to go. And it's just, it hits all the buttons. It hits the cost competitiveness. I mean, you're just, again, once it's in, it can work however long you need it to work. We can actually be able to compete globally. The quality level, I mean, to get to Six Sigma, you can't, if humans are doing it, you'll never get there, because it's just, well, you have to have additional features, check features, things like that. You can get to Six Sigma, but you have to put other features in. And it's just inherent in the robots is that you're going to achieve your quality levels. And then logistics matter. This past year and a half has been a nightmare. Nikki kind of mentioned it. We had parts shipments sitting on Puget Sound for weeks that we couldn't get to. We could see them, we could see the container, but we couldn't get it unloaded. And we're airing in, paying a lot to air parts in when the parts are literally 10 miles away and we can't get to them. This is the Long Beach. But what's happened is that has influenced the OEMs, and they've started to say, there's this term called local for local or local manufacturing, and there's a push for that. And so I think it creates a real window of opportunity for us as manufacturers to say, all right, we can provide you parts locally. And one reason we're across the US is for that reason, is so we can be regionally located by our customers. And it's really a cool time from that perspective. So manufacturing engineers with robotic cobot knowledge, 3D printing knowledge, and the mindset for technical solutions for production. It's, we have to come up with clever ways that help the operators be successful, and in order to get the quality levels we need. So that's my recommendation, is where you spend your energy. Anyway, and with that, you'll help us grow successful manufacturing in the US. So that's everything I have.
Thank you very
Thank you,
much,
Bridget.
Bridget. That was incredible.
Hey, Bridget, how
I'm
cost
sure.
effective are those cobots? This is Andrew. I mean, are
Super.
they?
So the basic, say, like there's different sizes and stuff, but say
Yeah.
like the one that was like taking a picture of that had the camera that I showed,
The
that the
UR5?
cobot, what's that?
I think it's a UR5. It's a 5 kilo, and they run like 35K.
Yeah, I was going to say it's around 40,000. The robot themselves are not the expensive part. It's always the figuring out all the other stuff and integrating,
Yeah.
but they're actually quite manageable. I mean,
I mean, that's the price of a good check fixture or what
right,
have you.
right.
So it's
Yeah,
interesting. Okay,
yeah. And
great.
that's where
Thank you so much.
yeah, so like an ABB, robot, like one of our ABB welding robots, they're more like 150, 200,000, and really specific, rigid, where the cobots are just have been highly flexible. The fact that you can nest them in with, especially, real estate's very expensive. Running a manufacturing plant, the cost is quite expensive for the property. If you can snuggle in robots with the people and not having to take a big, huge space for a traditional robot, it's really a good thing.
Richard, how do you find the speed of the cobot? That's one of the things I saw, is that they could be quite slow.
So yes, so absolutely, you want to do like the one that was doing the image taking. That happens to be the same, just slightly faster than the cycle time for the assembly. That's a 5-stage assembly, and it's like 15 minutes per station. And the cobot takes like 10 minutes to do the whole thing. And the faster you go, the more you need to protect it from people getting hit by it. And so, at the slower operations, you can easily get hit by it and it just stops and it doesn't hurt at all. But otherwise, you can kind of get a little bit of, if it's really cruising fast. So you have to, it's like anything else. What is your takt time? What's your cycle time? And what do you need the cobot function to do? They're going to move as fast as humans in general. And so if you're taking an old labor activity that a human was doing, the cobot can easily probably beat that time. And then just but doesn't need to. What are your downstream processes? Are they similar? We really try to do, kind of a theory of constraints and not overproduce with the robots.
Yeah, that makes sense now when I see what that timeline is. So yeah, that takt time. So
yeah, right.
Thanks.
And we slowed it down, like the camera thing that could have gone about 10 times faster than that, but we wanted it to be in the line by the people, and it didn't need to, because it was faster than the other upstream processes, and that way it could be there without a bunch of guardrails and stuff like that.
Bridget, this is Roger.
Hi.
Yeah, what ERP system are you guys using?
We use CSI it was Sightline before, and we just implemented this CSI. The reason we chose that is it's very flexible. I mean, it has like traditional work order, it has JIT schedules, you can do Kanbans in it, and you can do MRP or you can do APS in it. So we've been on it probably 15 years.
Yep. Interesting.
And we're very disciplined with it, because the transactions make all the difference in manufacturing, particularly when nothing's worse than not being able to ship while you're waiting for a penny PEM nut or something like that. So we really drive transactional accuracy on the floor, and we've been able to eliminate wall-to-wall inventories, and because of our accuracy and the auditing we have from outside firms that come in, the accounting firms, they don't require that any longer.
Well, Bridget, I want to thank you for your presentation and
Sure.
the pictures, especially, and the students in the group. We'll talk more about this in the afternoon session, but if you tour a facility like NIC and you see that they embrace lean, 5S concepts, all this stuff, they're clean, they're organized, it's a cultural indicator. These are the companies you want to pursue. They understand quality, they understand the impacts of it. And SME can be a great gateway to see into these companies as you look to find what to apply for. The question I had, the optimist in me wants to see the silver lining in COVID and all these supply chain issues to onshore more product. Is that accurate? Can we hope for that in the years to come?
Well, I think that I intended to present that I think there's absolutely a window of opportunity, but the issues remain. I mean, I mean, China is a manufacturing superpower. It's like when you go there and you're just like, holy shit. I mean, the stuff these guys do and the money they throw at the equipment and the automation and all that kind of stuff. And they're getting better at the lower volume stuff as well. But you've got the political unrest, you've got the logistics, you got all those other things. And if we can, I continue to maintain, if we can be creative and drive out the labor and drive out the variation and have the speed of inventory delivering regularly daily to customers being in their region, still practicing the lean activities, I think most of our customers would rather buy domestically if it's within 20% or 15% than take the risk of bringing it in from Asia.
That's great to know. And I see we still have Nikki in the room. Nikki, do you want to weigh in on this too? Is it a fool's errand to be optimistic about onshoring after COVID in the aerospace sector?
I don't think so at all. I think we're going to see a lot of that happening, especially on the defense side of things. I think the U.S. government understood our reliance on outside of the country for things that have an impact on our defense and our ability to defend the country is going to bring a lot of manufacturing back into the U.S. at least. And I wholeheartedly agree with what Bridget said. And I think that's somewhat the case in aerospace, that 20%, with logistics, with all the logistics nightmares and supply chain nightmares, that number could even go up for the price that people are willing to pay in addition to keep it closer to home.
Yeah, our containers have gone from $3,500 to $20,000 in 3 weeks to 6 to 16 weeks to get stuff over the last 6 months. It's starting to come back down a little bit, and the throughput is, but 2021 was the largest import year in U.S. history. I mean, everyone was sitting home buying stuff off Amazon, and it just overloaded the entire system. It just broke, and it's not an integrated system. It's, yeah.
The other consideration too is as the sustainability conversation gets bigger, the logistics, having shorter logistics lends to creating a more sustainable environment. So that's another factor that will bring manufacturing back into the U.S.
Yeah, and also with that is the longer the supply chain, the more chance of obsolescence, and you're doing bigger batches, you're bringing in, and so again, that ties into waste. Nothing's worse than throwing away something that human power and resources went into making, and now it's just discarded. And it's just, I mean, that's the kind of things that, as we look at sustainability, have to be considered too. And that's where kind of lean activities really help with that.
Mm-hmm.
Bridget, I feel I didn't give you the introduction you deserve earlier, and I'm sorry for that. Everybody, if you didn't catch this, Bridget is the president of NIC Global, and she's also a member of the Operations Advisory Board at Western, just for those like students and Professor Hoekstra.
I would like to celebrate for a moment how cool it is to have such high level perspective from people like Nikki and Bridget, especially for our student members in the room. It's a very unique opportunity to sit at the same table with people like this and not wait 20 years in industry to be in the same room to understand industry perspective. So thank you both.
Yeah, that was a fantastic breakdown, Bridget. That just
Thank
that
you.
covered kind of the advantages and disadvantages of robotics better than basically the past 2 years of trying to and figure this stuff out myself.
Yeah, it's amazing too, because as you know, as we look for engineers, it still surprises me how few robotics experts are coming out of school, or even out there in the workplace. It's you know, it's like there needs to be it needs to be part of a greater part of the curriculum or whatever, or some tract related to that.
Absolutely.
Yeah.
Well, Bill, what's your take on what UW is embracing right now with robots, cobots, all that? What's the curriculum looking like?
We're kind of lucky. We have a couple of professors within the department who mechatronics and robotics happens to be their forte. So that's a highly sought after elective course. Fire robots.
We can hear you.
Again.
You're a little soft, Bill.
Sorry, I'll speak up a little bit. I was just saying that we've got a great faculty that support mechatronics pretty extensively, along with the fact that Trickfire Robots, the club that's on campus, has a whole grunge of mechanical engineers in it. So they get a lot of effective use in that, along with our capstone, two or maybe three of the groups are specific in robotics, the rover competitions and so forth. So we're pretty well situated, and that's our position. Thanks for asking, Matt. But it was encouraging to hear the plug that you were asking at the end. The engineers you're looking for obviously have that sort of capacity in their background. Awesome.
Yeah, I think a lot of times the people who are really good at robotics are not interested in manufacturing. It's not a very glamorous career path for a lot of people, and it's, you know.
Well, I want to commend you again for your presentation. What you do is you put this into context, and to Matt's point, I really work hard at trying to give students context. I want to build cars and I want to work on airplanes, and I'm not knocking the aerospace industry, but they don't necessarily understand the variety of the things they can still do and not work for either of those two primary industries.
Right.
They could go work for NIC Global and they could have, to their heart's content in robotics, just trying to make sure they're giving you the support you need.
Right. And they it's not automotive, but they can make truck parts, and, it's really,
Totally.
that kind of
Maybe I can chime in. So this is Carl Hoppola from Oregon State University. So here there's a large robotics group also that spans across our mechanical engineering and electrical engineering and computer science schools. So that's an opportunity. But I think a lot of those students too, it's more at the graduate level, and a lot of those students are interested in the, what we would say, the cool robots, right? So
Yeah.
the walking robots and the snake robots.
Yeah, right. Exactly.
Yeah.
The glamorous part.
Yeah.
Pick up a part and put it on a prototype.
We do have advanced manufacturing faculty, and two of those have expertise in mechatronics. In fact, 2 years ago, we got an NSF grant to kind of help meet this need through the development of an online certificate program. So that's going to be launching this year. It's actually on the books, and the first track of students should be starting this spring. But what NSF was really looking for there was tie-ins with 2-year programs. So we've partnered with Clackamas Community College in the Portland area, and so we're developing a certificate at that level with them, and hoping to roll that out to other community colleges that want to take advantage of it. And then also they were really focused on professionals that are out working and upskilling them. So we've kind of said, can we take advantage of students that went out as undergrads in mechanical engineering but didn't have that mechatronics expertise? So anyway, if anyone's interested, I can share more about that. Especially, we'll be wanting to get people signed up to take the classes and get that. So, especially if there's, if you know of anybody, but also if you're able to help us communicate the need for this kind of expertise out in industry that could be helpful. And so the idea there is that the classes are online, they can be taken asynchronously, and so anyone can take it anywhere.
Yeah, I think the difference here is that the cost of these robots are coming down, so that it's becoming another tool that the manufacturing engineer can use to solve their problems. I think they have to be knowledgeable of what these robots can do, how much they cost, and be able to build a business case to employing these where there's a good fit. So I think that that's the opportunity for engineers out there in the future, and those new engineers who come out are not intimidated by installing a new robot online next to let's say another individual, a human, and I think that kind of thought process is just as valuable as the ability to design or program the thing.
Yeah, I think, well, understanding too what the, why it's really driven by the quality and efficiency and surviving as a company. And so making sure everyone culturally in the company is aware of why we're investing in cobots. And it's not meant to displace labor persons on the line. It's meant to help them and to get rid of the mindless work and make the other work more meaningful. And we try really hard to communicate that and help people, because no one wants to get a reject from the customer and know that they made that unit that had that, bracket missing or whatever. But you're right, Andrew, that the cost threshold coming down really makes it achievable for companies like my size to be able to utilize it more and more. And when you don't have a million, you're not producing a million of something a year, and it's easy to amortize it over that many parts. Yeah.
Carl, I want to thank you for joining us today.
Yeah.
Oregon. Are you able to drop your email or contact info in the chat?
Yeah, I can do that.
Okay, or send it to me privately, whatever you're comfortable with. We just want to make sure we include you in future conversations on this stuff.
Yeah, this is exciting.
Really
I
good
would
conversation.
I'd also emphasize it's a bit of a hobby or a pet peeve of mine that there's a kind of a de-emphasis on end-of-arm tooling as part of the curriculum in robotics. There's a lot of discussion on the actual robot part of robots, the transformation or transforms. But when you go looking for literature about designing the actual tool that makes the robot possible, there's nothing.
Yeah, that's a good point.
And yet, when you get down to it, a robot without an end-of-arm tool is toy.
Well, like that one with the camera one, because it's camera inspection is very particular, especially with sheet metal, because there's so much reflecting, and you have to have, like, we've had to create diffuse light boxes for other inspections we have, like on silkscreen and whatnot. But the camera, this particular camera, is more like a laser scanner, and trying to find the information about that laser scanner and the unit controlling, being able to integrate those, was the engineer that worked on it, who was very smart. He struggled mightily to find anyone that could help us navigate through that. It was really tough, and there was not good information out there.
Which I think brings up a really good point to the handful of students we have. I can say firsthand challenges like this, like with a laser scanner. I had to bust open a 400-page PDF about from Design X and a roamer arm, and no one else wanted to figure it out, but I did. And then I was the reverse engineering guy for the entire foundry. It had collected dust for over a year and a half. So having the curiosity and the drive to crack open a book, to be a self-starter, and then you're the leader. You know the technology. We're bringing data to a team that couldn't explain castings inside and out like they can with that technology. It's such a huge value add to have the courage to break open these big complex tasks and go for it.
Yeah, that's the part that I guess I was, talking about, is like, it's kind of surprising how few experts there are out there on this kind of thing. And I know, I mean, I'm an engineer and I know how much stuff you have to cover, and like cramming another thing in there, like you need to know mechatronics is, you know, you're always trading off different knowledge and that, but you know, maybe integrating it in the capstone projects or something that puts that hook of foundation into it. It's just,
Yeah, we're going through I'm the program coordinator for our manufacturing program, but I'm also involved with the mechanical engineering undergraduate program committee this year, and they're going through a reorg right now. Actually, we'll have to still vote on it as a faculty, and that'll be interesting. But anyway, the idea is to go to a core curriculum with options, and one of the options that's being proposed as an initial option is called robotics and control. So taking advantage of those robotics courses and also these new mechatronics courses we're developing. So hopefully in a few years, we might be a few years too late, but you know, there should be some students coming out, at least from down this way, that can help meet those needs.
Yeah, you know, it's an interesting thought process. You brought up the capstone project. When we were just having a brainstorming session on, well, yesterday at PACCAR, we sponsor a capstone project at Washington State University. It just happens that that's why. But knowing what the capabilities of the students in the lab, and you know, it's tough coming up with right size capstone projects for students. So the more you can do to help guide that, you know, we can start thinking about those. You know, maybe these robotic projects could be, you know, good self starters. In fact, we're actually going to do a mini robotic project for next year, and it'll probably be some sort of cobot or who knows what. But interesting thought on, you know, how we might integrate practical, you know, because we need help from industry on the practical use of these new technologies. And the students coming out have the skills to do it, but don't have the real world opportunities. So where we can bridge, I think we can help each other and bridge that gap.
Well, Bridget Brewer, I think we're all having a great time talking, and if you don't mind, we'd love to have you back again for another conversation. I think we can all talk about robots at length for
yes.
a long time. But we did kind of our agenda does say that it's right about now we need to start moving on to the next point. But again, thank you very much for your participation.
Sure, it's nice chatting with you guys, and I'm gonna go ahead and hop off the
yeah. And if possible, if you wouldn't mind, we'd love to have you again for another event. We can figure out the precise contours of that, but clearly there's an interest in robotics, and you and your team are some of the most capable people I've met in the area.
Yeah, it kind of just hits a lot of the hot buttons out there right now in terms of industry challenges.
Yeah. But again, thank you for your time.
Sure.
Okay.
Talk to everyone later then.
Yeah, talk to you later.
Okay.
Yeah.
Good day. Thank you.
Have a good day.
Bye-bye.